Hello everyone, we are from Group 12. Today, we are gonna presentation about our report. The title is Application of Artificial Intelligence in the Field of Agriculture for Detection of Fruit or Vegetable, Rapiness and Pests. Our member here we have five people. The first is our leader is Felix Evans. The second is Christina Chow. The third is Melisa. The fourth is Fiona Livianti. The fifth is Navelina. First, we have the abstract. In the abstract, we have a background. The background is technology has advanced quickly over the years, which has led to numerous of invention and innovation of technology that we can use today for our benefit. The second is method. Using the YOLO's version 5 algorithm. The result, the concept of YOLO version 5 and how to implement AI in agriculture to help farmers identify and select fruit and vegetable ripeness, along with identifying pests that inhibited the farmers' farm that can ruin the crops. The fourth is consolation. Rapid text progress has yielded many innovations including artificial intelligence. AI impacts various sectors like education, economics, and agriculture. Manual refinance selection in agriculture lacks consistency, and pest damage crops. AI, particularly YOLO version 5, enhance selection and pest control effectively.
Let's start an introduction about the topic that we are going to discuss. First is one of the tools that have been created and used in our daily life is artificial intelligence or AI. In this paper, we are going to discuss about how implementing AI can help in the field of agriculture. What we meant in this is that in detail we want to talk about the process of selection for fruits and vegetables because we believe that by implementing AI we can bring more benefits to farmers by using AI. There are many more benefits that can be brought from implementing AI into the field of agriculture. Now, let's talk about theoretical basis. First off, what is agriculture? Well, agriculture is an important sector in providing food and fulfilling human needs. However, challenges in conventional farming, such as limitation on land, climate change, and increasing populations, have driven the development of methods for more effective and efficient agriculture. What is AI? Well, AI is basically a computer program created by humans that has algorithm with the ability to study data and use data to be able to process, think, and work like humans. Well, AI can help overcome some of the problems that are often faced by farmers and provide solutions to overcome these problems. For example, AI can detect pests and provide suggestions for dealing with pest problems. AI can detect soil fertility and provide suggestions for maintaining or increasing soil fertility. AI can also detect the latest weather or temperature and can advise farmers to be aware of it. Now, this is the algorithm that we are going to use. It's basically called YOLO, or you only look once. What is this? Well, YOLO is basically an algorithm that is used to be able to detect objects according to the categories that has been trained and then can detect them very quickly in real time. Now, this study aims to discuss about implementing and how using AI can benefit farmers by helping them to detect objects like fruits and vegetables, their crops, but also use as pest control, a technology that can help identify objects in real time. This detection system is very helpful for farmers for giving them control over their farming.
Next is research method. Our study employs a literature review method involving comprehensive analysis and synthesis of information from various sources. Descriptive analysis was used to decipher and explain findings. One key is focus is YOLO-5, a cutting-edge object detection algorithm within the YOLO family. Known for its high processing speed and accuracy, YOLO-5 is suitable for real-time applications. Additionally, we explore Google Colab, an executable document enabling collaborative coding, editing, and sharing via Google Drive. Similar to Jupyter Notebook, it supports Python scripting, adding versatility to our research process.
Next, there is result and discussion. In the results of this discussion, we discussed the concept of YOLO version 5 and how to implement AI in agriculture to help farmers identify and select fruits and vegetable ripeness, along with identifying pests that inhibit the farmer's farm that can ruin the crops. YOLO version 5 uses an algorithm that generates anchor box-shaped constraints in the detection of box in images. This is one of the reasons why YOLO version 5 is the right choice for this implementation. Detection of roots, vegetables, and pests is done visually, which means the process uses a photo or camera to capture the image or appearance of the fruit or vegetable to be detected as input. The input results are as data to be processed and classified according to predefined parameters. What must be done first is to first collect a dataset in the form of root or vegetable images and past images that have been uploaded to Google Colab. Then label the images of each object. After the dataset has been collected and the object labeled, the dataset is ready to be used in training. Entering the training process has several stages that must be passed. The first is entering the dataset that has been collected and labeled. This stage is important because the dataset that is entered must be detailed, so that object detection can be carried out accurately and stably. After the dataset has been successfully entered, the next step is to conduct training on the dataset using the Google Colab system. Then after successful training, object detection from various distances and angles is carried out for testing. If the test results are successful in detecting the object correctly, then the next step is to carry out the evaluation stage. The evaluation stage is the stage where the evaluation process is carried out to see the accuracy of object detection from the results of the previous training dataset. This is necessary because for stable object detection, a high accuracy value is required. Therefore, this stage must be carried out carefully to prevent future complications. The test for identifying pests is also done the same way as before. The output results can be said to be successful if the detection of using the YOLO version 5 algorithm method is successful in detecting the various objects provided correctly and accurately.
Now I'm Fiona Livianti with NPM 2131086. Will tell you about our conclusion. So conclusion, rapid technological advancement optimized by artificial intelligence or AI is transforming industries and enchanting efficiency. AI's innovations span diverse sectors, includes including business, economy, health, and even agriculture. While manual methods for fruit and vegetable section suffer from subjectivity, AI offers a solution by facilitating precise, consistent, and objective detection. This study delved into a more efficient approach for detecting fruits and vegetable ripeness, utilizing the YOLO V5 algorithm for real-time object detection. By harnessing AI's potential, particularly through the YOLO algorithm, this research showcased the promise of improved accuracy and efficiency compared to current manual methods. The study involves literal reviews, YOLO V5 exploration, and AI implementation in agriculture, underpinned by rigorous training and testing. Ultimately, this research provides value insights into AI potential in revolutionizing agriculture practice for enchanted outcomes. That's it for our presentation. Thank you for listening, and I'm sorry if we have wrong words that offend you. Thank you.